Okay, artificial horizon, flat Earth, attitude indicator, Earth gyroscope versus space gyroscopes, and my favorite sentence to say all week, because this is completely legitimate. Pendulous erection mechanism unit. Actually, it's pendulous unit erection mechanism. Either way, it sounds really, really wrong, and I loved saying it. Okay, now we're going to go on to this. Attitude indicator is the proper term for an artificial horizon. The reason this video is up is because a bunch of people have decided to use this, because they're grasping at straws, to say that the Earth must be flat, because it's gyroscope based. Therefore, since a gyroscope always points one direction from when it started, it should move as you fly over the Earth. That would be completely accurate if it was really just a gyroscope, or more accurately, if it was most likely just dominantly, it was dominated by gyroscopic effects. It is not. It is, well, it's an artificial horizon or attitude indicator because it's supposed to be correct, pointing towards the gravitational center of the Earth. Obviously, it wouldn't be based on gyroscopes, it would be based on gravity. Gyroscope, the part of it that is a gyroscope, is only really important if you're doing something where gravity would be confusing, because that's important. The reason these are in airplanes is that if you're flying an airplane, when you fly it dynamically, where you're throwing yourself around in the cockpit, that makes it to where you can't tell where up and down is, because gravity doesn't make sense anymore because you're moving too fast. You're also in a vehicle that can turn upside down. Obviously, if you're in a swooping dive and then you pull up and go in a circle, you won't know whether or not gravity is correct. That's why you have an artificial horizon or attitude indicator. That's why you see them in the movies. They're rolling and all that kind of stuff. That's because you can't detect gravity anymore. And guess what? Because you can't, it couldn't either, so it uses a gyroscope temporarily during those sorts of maneuvers to show you what the gravity would be. That's it. This is also used for instrument landings and for flying through fog, and to make sure that you don't run into a mountaintop by really flying level, which you can't tell plus or minus 1 degree. So it's based on gravity. It uses a gyroscope again to stabilize it. So this is a gyroscopically stabilized plumb bob or level. Coincidentally, the next picture over is a picture of a non-stabilized, as you can see because it's tilting slightly, compass in oil. And below it is a tilt indicator in oil that's a metal little round ball that is also used for the same reason, because these are a little bit more reliable than your senses. Then on the far right upper end is a ring laser that is used to, I don't know how it works, but basically it responds a little bit more finely and more correctly than would a gyroscope. And it's referred to as a ring gyroscope or laser ring gyroscope or something. The lower left shows you the pendulous unit on the erection mechanism at the bottom of the enclosed gyroscope, which is really just an electric motor's armature spinning. It uses, in that case, vacuum pressure to drive it and also to force it to compensate. Anytime there's any kind of hard movement, it dominates and becomes the gyroscopic effect. If it's not, then it automatically adjusts for positioning based on gravity because it's slightly bottom heavy. Yes, there's a joke there anyway. The next image over, that's also gray and white, the second one on the lower left is the next one over, is the one that you see on Wikipedia that doesn't really show you anything except one button that says pull to turn, and it's for setting adjustments to compensate when, not if, your artificial horizon gets messed up, because if you travel 70 miles or so, or 111 kilometers, it will be wrong by 1 degree because the Earth is round. And also, if you're just sitting there, it'll be wrong eventually unless it auto-compensates or is simply turned off and is just using gravity. Again, even if you're sitting there at the airport, it'll be off within less than an hour because the Earth is rotating on its axis. This is something well understood and is part of all of the patent applications describing how to make one of these work. Next image over is the apparently air-driven, they say vacuum-driven, drive mechanism for this gyroscope. Now, in the middle on the right is an actual gyroscope that's used for one of 3 gyroscopic positions. Yes, you can set a gyroscope, and it will give you information about deviations in 1 or 2 directions, but it won't do it in one of them because it's the same one it's rotating as. So airplanes normally have more than one gyroscope. And then on the lower right part is one of the screenshots of the gyroscope people keep using in these videos, trying to prove gyroscopes don't work the way they do. By the way, I should remind everybody, the one on the right that's made on lasers in the upper right-hand corner is much more expensive and much more precise than the one below it that will get you around the world without actually being wrong by too far. And the one below that is a toy. There is no comparison even between the top and second one, and there's definitely no comparison between the bottom one and any of them. It's the only one I'm putting there that is not a gyroscope that you would want to trust your life with or navigation with because it is a toy. Also because it won't be able to detect the rotation of the Earth because it's so poorly made it won't do it. It's too roughly designed. It's very precise from a normal person's standpoint, but it doesn't respond to tiny changes in the Earth's rotation or even travel. Artificial horizons, otherwise known as attitude indicators, compensate for the fact that as the Earth rotates on its axis or you travel every 111 kilometers, for instance, or just 70 miles, you're going to get 1 degree of error. The righting of a gyroscope, however, is not an inherent property of gyroscopes. Unfortunately, a person who goes into the name Armored Skeptic made a video claiming that he was wrong actually. Gyroscopes do actually, if they're really, really precisely designed and insanely expensive, they will actually orient themselves in a way that doesn't change. And if you can keep them going long enough for a 24-hour period of time, they will literally do 1 flip-flop. But that would require you to have one that would be good enough for you to load into an ICBM, and I don't think the U.S. government wants you making those. That's aerospace grade stuff. You don't have those. Unless you have one of those, you can't do this experiment because it really won't work otherwise. There's too much friction in a toy. The righting of the gyroscope is based on gravity. It is the dominant characteristic. The gyroscope merely stabilizes it during dynamic flight because that's what it's for. A space gyroscope, however, will move in all 3 planes while stabilized to a fixed reference point at startup. And you will see these move due to traveling a distance or to the Earth's rotation very nicely. If you want to spend about $250,000, you can get one and you can do the experiment. And they would be totally useless for an aircraft because they would keep changing position when really it's just supposed to point down, or more accurately tell you when you're pointing down so you don't fly straight into the dirt. Artificial horizons and attitude indicators use an Earth gyroscope. That is a gyroscope that has freedom of movement in all 3 planes, but is held to the horizontal periodically through Earth's gravity by a pendulous unit called an erection mechanism, which determines up and down and nothing else, and maintains it by literally making it position itself at a rate of 3 to 5 degrees per minute maximum, which means if you really screw it up, every minute or so it will force it to be correct. It'll wait for when your airplane is not moving badly or you're not moving dynamically and literally yank it into position to keep you from having the wrong reading because you need to know where the horizon is or whether or not you're flying level, because if you don't, you'll run into something like a mountaintop or the ground. And again, a space gyroscope that does what the flat earthers are talking about would be absolutely worthless in an aircraft, and also probably get out of alignment even on a flat Earth. The whole point is this is supposed to be a gravity-based device, not a gyroscope-based device. It's for stabilizing it. And they continuously adjust to the local level or downward acceleration vector, which is commonly called gravity, because we treat gravity as an acceleration. That's why you can use accelerometers to find it. This is added to compensate for the curvature and rotation of the Earth, and if it wasn't being done, it would maintain its same axis of rotation relative to distant stars that you could point it at, so you could fly along the curved surface of the Earth or just hold still as the Earth rotates with you and have it show you the wrong thing and potentially cause you to die. That's bad, so it doesn't do that. So this is a dumb comparison. Traditional self-contained attitude indicators used a powered gyroscope, basically a motor armature, to establish an inertial and internal platform as a basis for things. The gyroscope is geared to a display that has 2 degrees of freedom only, simultaneously displaying pitch and bank only. Modern AHRS units are 3-dimensional magnetometers and accelerometers used in conjunction with GPS to detect the airplane's pitch and roll attitude rather than using a spinning rotor for anything. Like the old systems using gyro horizon indicator, and I looked up the patent for it, AN 5736-1, which at one time was a military secret because it worked. In the 1980s, however, all of this became moot because most aircraft that were being built were given ring laser gyroscopes without the slightest resemblance or in principle or operation to any of the other devices we talked about. The ones on modern airplanes don't use anything like a gyroscope at all. It's called a gyroscope, but it's called a ring laser gyroscope. The principle is so completely, utterly removed from this that I'm not even going to cover it in this video because I can't. It's not a gyroscope. It's something to find level. That's it. And it has to be insanely precise because you're flying higher, faster, in cramped environments with very, very unhappy air traffic controllers that don't want to hear that something broke, because then they'll let you run into a building. Anyway, their mechanical forebears, mechanical gyroscopes, are now gone in most aircraft. If you're on an international flight, it probably has no gyroscope like that for that particular purpose. It may have others. It may use all sorts of things. As for what is a pendulous unit, I'm only going to cover a little of it. I'm not going to cover the vacuum-based one because I'm not going to go there. That's too much work and I don't even understand it completely. But anyway, most of them were based on electric attitude indicators using mercury switches to detect when they were wrong, torque motors which detected when they were wrong, anything else they could get away with to keep the gyro horizontal, while some systems used steel balls or liquid mercury, for instance, spread out evenly so that when the gyro was spinning properly, the gyro would be stable. But if it went out of position, the balls or liquid would move the low side, and this unbalanced force resulted in redirecting itself strictly for gravity. Basically, they would cheat the thing and make it work. I'm not going to go into describing the vanes and vacuum-driven stuff. I'm only going to say that you can look this up. Now, again, I'm going to repeat. Upper right-hand corner is the laser-guided thing that's been around since the 80s that is used on most of the big airplanes that people were using in these videos I saw on YouTube. And it doesn't use a gyroscope. Because it doesn't. Because a gyroscope would be worthless. It's better to have something that orients towards the gravitational pull of the Earth. The next one, below it, is one that does this, and it uses a caging mechanism. It's a button that pushes it to force it to position itself just based on gravity, turning off the motor in some cases, and then resetting itself and starting again. Because it gets messed up all the time, because gyroscopes are pretty much not really all that useful for maintaining horizon, because the Earth rotates on its axis, and you're flying maybe a degree of deviation every hour or less. And then I'm going to point out at the bottom, a gyroscope, which while it may be expensive or really well made, is essentially not just a toy, a primitive joke compared to everything else on the screen. And is not a good analogy for it, because artificial horizons and attitude indicators are not gyroscopes. They're devices to find gravitational up and down, and that's it. And they use gyroscopic stabilization during dynamic flight maneuvers almost entirely only. The dominant behavior is gravity, not the gyroscope. And everybody uploading a video arguing this point and saying otherwise knows they're saying something that isn't true. And they've been corrected in the comment sections of most of the videos I looked at, and they just ignore that because it's not about whether the Earth is flat. It's not about whether there's some sort of conspiracy. It's about being an antagonistic, cantankerous, contrarian jerk on the internet and being able to annoy people. It has nothing to do with anything else, guys and gals. And I'd like to point out again that every one of them showed a picture of one of these things and has an adjustment knob to fix it when, not if, the gyroscope is wrong. Thank you for watching. Have a good day. And I wish everyone a great deal of luck with all of that.